Hello and welcome to our lesson on graphing quadratic functions. This is going to be from section 7.5 in our text. We've got a lot to get through in this lesson, so let's go ahead and get started. First, we have some forms and formulas that we need to at least refer to here, starting with standard form, which you may recall that from our previous section. The standard form of a quadratic equation. Here we have the standard form of a quadratic function. Next, vertex form, which is another form of a quadratic function, where h and k is the vertex. And we will later talk about specifically what the vertex is. And our last formula, the formula for finding the vertex of the quadratic function. This vertex formula is going to depend on your function being in standard form. Notice the vertex formula involves the values of a and b, which will come from standard form. Now, what are we going to find in this lesson? Well, things we're going to find are the vertex, the axis of symmetry. We're going to determine if the function has a maximum or minimum value, and we're going to find that maximum or minimum value. We are going to determine the domain and range, the intervals on which the function is increasing and decreasing, and last but not least, we will sketch the graph. Okay, so before we get started on the laundry list of things we're going to look at, what I would like to mention first is the fact that you may be required on some occasions to convert your quadratic function from standard form into vertex form or vice versa. Actually, that's the first concept we're going to look at here, is how to convert from standard form into vertex form, and then how to convert from vertex form back into standard form. So our first example here is in standard form. We can see that A is 3, B is -5, and C is 6. And there are two techniques that are taught to convert from standard form into vertex form. One of them is easier than the other. So what I'm going to do is I'm going to show you the hard way first, or I'm sorry, what I consider the hard way, and then I'll show you the easier method. So the first technique we're going to use to convert from standard form into vertex form is completing the square. So in order to complete the square here, what we're going to have to do is group the first two terms together, and if there is a lead coefficient, you are going to have to factor that out. Now, since 3 doesn't go into 5 evenly, that's going to make this even more challenging. Or I guess you could say it's going to make it more fun. So let's factor out the 3 from the first two terms. That's going to leave me with x squared minus, now 3 doesn't go into 5 evenly, so we're going to say 5/3 x. And you'll see if you distribute that 3 back in, the 3's will cancel and leave you the -5. So that is factored out correctly. We are going to have to add plus, and then we're going to come up with some constant that will complete the square. So we're just going to leave that space blank for the time being. The plus 6 carries down outside the parentheses. And since we are adding a value that is not already present, to compensate, since we're only working on the right-hand side, we will have to subtract that value to make it even out. So normally you say whatever you do to one side, you have to do to the other, but we're not allowed to work on this side. So whatever you add to one side, you have to subtract from the same side to keep the balance. Now, let's complete the square. And the process of completing the square says that you take half of the value of b. Now, taking half of a fraction, if you're thinking about just dividing by 2, that can be challenging also. But if you break it down English to math, half of something, the word of in math means times, and it means you're actually multiplying by a half. So to take half of negative 5/3 means to multiply negative 5/3 by a half, and that will make negative 5/6. That value needs to be squared in order to complete the square. So the process of completing the square says that you take half of b and then square that, and that will give you your constant that we need. That value is going to be 25/36. So remember I said whatever you add to one side, you have to subtract from the same side in order to keep the balance. But since the 25/36 is within the parentheses, that means that it is affected by the 3 out front. So I'm going to have to distribute the 3 to see what I really added so that I know what I really should subtract here. So here we go. 3 times 25/36. 3 goes into 36 12 times. And so what I really added was 25/12. So 25/12 is what I'm going to have to subtract. Now we need to simplify. So our function currently is 3 times this trinomial, since we completed the square, will factor as a perfect square. So we're going to have x minus, and then it's going to be the square root of this number, which is 5/6. So that is how that trinomial is going to factor. And then I need to combine like terms at the back. Now, in order to do that, I'm going to need a common denominator. The 6 is understood to be over 1. The common denominator would be 12. So 6 over 1 converted into 12ths would be 72 twelfths, right? 72 divided by 12 is 6, minus 25 twelfths, and that works out to be positive 47 twelfths. And now we're going to put a box around that because that is now in vertex form. And just to point out here, the value of A is 3, H is 5/6, and K is 47 twelfths. And so if we wanted to, we could state the vertex. The vertex, if I scroll up, remember, is the ordered pair H comma K, which would be 5/6 comma 47 twelfths. And that is converting from standard form to vertex form using the completing the square method. The next thing I want to do is I want to demonstrate using the same function how to convert using the vertex formula. So I'm going to call this example 2, even though it's the same function and we're finding the same thing, we're going to be using a different technique. If I want to convert from standard form to vertex form, and I don't want to have to complete the square, what I can do is just make a note here of A, B, and C, and I can plug into the vertex formula. So the vertex formula says minus B over 2A, comma, F of minus B over 2A. So what we have here, this is the x coordinate of the vertex, and this is the y coordinate of the vertex. Whatever we calculate for the x coordinate, notice we're going to plug that into the function to get the y coordinate of the vertex. So minus b Since b is already negative, that's going to make that positive 5. That's minus b over 2a, and then f of whatever we get from that value. So 5 over 2 times 3, that's going to simplify to 5/6, and then we're going to have to do f of 5/6. Now that's not bad if you have a calculator. To do f of 5/6, you simply need to replace each x with 5/6. And again, with our particular calculator, the Casio ClassWiz, that is a piece of cake. So that's 3 times 5/6 squared minus 5 times 5/6 plus 6. And it gives us 47/12. So the y-coordinate of the vertex is going to be 47/12. And I would like to point out that that does correspond to the vertex that we got in the previous method. Now, to write the vertex form, once you have the vertex, again, that is freaking easy. We're just going to say f of x equals, vertex form says a x minus h squared plus k. So a is 3, x minus h is 5/6 squared plus k 47/12. And we're going to put a box around that. Notice that that is the same vertex formula that we had previously. So that shows that there's two ways to convert from standard form to vertex form, one with completing the square and one with just using the vertex formula. So the next example that I want to look at is how to convert from vertex form back into standard form. I can't imagine why you would ever want to do that, but this is how you do it. And unlike the other direction where there's two techniques, going from vertex form to standard form, there is only one method for that. So it would be nice if we noticed that this is vertex form. Vertex form is f of x equals a x minus h squared plus k. And we can see that our function lines up with vertex form. So to convert into standard form, the first thing we're going to do is, well, we're going to do the four-letter F word. We're going to FOIL the x minus a half squared. So to FOIL, we're going to go x times x, which is x squared. On the outside, we have a negative 1/2 x. On the inside, a negative 1/2 x. And last but not least, negative times a negative makes a positive. And a half times a half is a fourth. Don't forget that all of that is in parentheses. All of that's going to need to be multiplied by the 5, and the minus 4 comes down. Next step, we're going to have f of x equals 5 times. We need to combine like terms. X squared minus a half and minus a half is minus 1x plus a fourth, and the minus 4 comes down. And next we need to distribute the 5. And so that's going to give us f of x is 5x squared minus 5x plus 5/4, and the minus 4 comes down. And we're finally to the last step, where we simply need to combine like terms one more time, and that'll give us our function in standard form. 5x squared minus 5x, and to add these numbers, or in this case subtract, we're going to need a common denominator. So the 4 is understood to be over 1. That's going to be the same as 5/4 minus 16/4. 5 minus 16 is negative 11 fourths. And we're going to put a box around that because we're done. We are now in standard form. Okay, now before I move on, one thing I haven't mentioned yet. If you're not sure whether your math is correct, what you can do is you can use Desmos to check. So what I've done here, if you'll notice, the initial function I have graphed in Desmos, that is the red graph. And then the other function here is my standard form. This is the answer I came up with. And if my math is correct, if I graph both of these functions, they should produce the same graph. So when I turn this function on, if it's not overlapping, if it's not the same graph, then these are not the same function and I screwed something up. And it matches perfectly. Not only that, if you notice from the vertex form here, I can see the vertex is going to be 1/2 negative 4. And if I click at the vertex, Desmos is going to verify that for me, 1/2 negative 4. So the vertex of the parabola is either the highest or the lowest point on the graph, or you could call it the point of symmetry. It's right in the middle of the parabola. And Desmos gives that to you by simply clicking on the vertex. So that's one way using Desmos that you can verify your work electronically. So now that we've discussed converting back and forth between standard form and vertex form, it's time to get down to business. We're going to focus on the actual meat and potatoes of this lesson, which is finding stuff. We're going to focus on finding the vertex, axis of symmetry, maximum, minimum, values, where it exists, domain and range, increasing and decreasing, and sketching the graph. So what I thought we would do is start with number 24 because it's, in my opinion, easier to do all of that work if your function is in vertex form, which number 24 is. And to illustrate that, I'm going to copy down vertex form right underneath that. So that's f of x equals a x minus h squared plus k. And the first thing that we're going to do is we're going to determine whether this graph opens up or down. That is probably the easiest thing to start with, okay? And I'm going to label this part A. Does it open up or down? Well, the way you determine that is you look at the value of A. If A is positive, your parabola opens up. That means it's going to make a parabola up like that. If A is negative, then it will open down. Super easy in either form to determine whether the parabola opens up or down. Next, easiest thing to do, once you've determined whether it opens up or down, then you can determine whether it's going to have a minimum or a maximum value. So if your parabola opens up, you're going to have a minimum. If your parabola opens down, then you have a maximum. And let me see if I can make that make sense. If your parabola opens up, like so, then the vertex, which is the center point, will be your lowest point on the graph, which that means it will be the minimum value. However, if your parabola opens down, like so, then your vertex will be the highest point, which would correspond to a maximum. Now, part C, we're going to find the vertex. If your function is in vertex form, the vertex is going to be the ordered pair h comma k. So all we need to do is find the values for h and k and then plug them into the ordered pair. Again, super easy. If you come up here to where I wrote down the formula, we can see that negative h is negative 1. So that means that h is 1. And the way I remember that, the easy thing is whatever is in the position of h, it's always going to be the opposite of what you see. Okay, listen to this. H is opposite, k is not. So h is going to be positive 1. K is going to be negative 4. And so there is our vertex as an ordered pair. Part D, we're going to determine where the minimum occurs at and what it is. Those are two different questions. So the minimum occurs at the x coordinate of the vertex. So our minimum occurs at 1, but we have a minimum value of negative 4. The minimum value is the y coordinate of the vertex, but the minimum occurs at the x coordinate of the vertex. And so that makes knowing the vertex kind of important. Okay, the next easiest thing to find probably would be the axis of symmetry. And I'm going to abbreviate that AOS. That's the axis of symmetry, which for a parabolic function meaning it passes the vertical line test, the axis of symmetry is always going to be x equal the x coordinate of the vertex. So our x coordinate of the vertex was 1. So the axis of symmetry is going to be x equal 1. Next, part F, we're going to determine the intervals on which the function is increasing and decreasing. And again, this is going to be super easy if you combine two pieces of information. The fact that the parabola opens up and the vertex. We're going to put those two pieces together. So the parabola opens up. So I'm going to sketch a quick little graph of that. And the vertex is at 1, negative 4. So what we can see here, if I draw the axis of symmetry, which by the way is the vertical line that cuts the parabola in half, we can see that this function is decreasing, going from left to right until we hit the vertex, and then it starts increasing. So since the intervals of increasing and decreasing represent the graph from left to right, then those are going to correspond to x values. So this graph is going to decrease from negative infinity up to the x coordinate of the vertex, right? It's decreasing on this side, which means from 1 as far back as I want to go, which is negative infinity. And then at 1, once I pass 1, it's going to increase forever to infinity. So the increasing would be from 1 to infinity. Now, do you see that those have to be from left to right? From negative infinity up to 1 is decreasing, and then from 1 to infinity is increasing. And that takes care of that concept. Next, part G, I think the next thing that we can find super easy would be the domain and range. Yeah, especially the domain of any parabolic function, that's super easy. That's always going to be from negative infinity to infinity. Remember, the domain are the values that x can be. And for a parabolic function like we have, it's going to go to the left forever. It's never going to have a point of discontinuity, which means it's going to be continuous. And then it's going to continue to the right forever. So just remember the domain of any quadratic function or polynomial function for that matter is all real numbers, Minus infinity to infinity is the interval notation for all real numbers. And the range is going to depend on, again, the direction that the parabola opens, which is up in this case, and the vertex. So one more time, remember this parabola opens up with a vertex of 1, -4, and the range are the values that y can be. So since we have a minimum, we know the lowest point on this graph is at -4. Okay, that's the smallest that y can be. So the range is going to be everything from -4. We use a bracket because -4 is included, and it's going to go up forever. So the values that y can be are everything from -4, including -4, to infinity. Part H, let's find the x-intercepts. X-intercepts are going to be fun. Remember, to find the x-intercepts, you need to let y be 0. So going back to our original function, remember f of x means y, so we're going to replace f of x with 0. So that's going to give us 0 equals 2 times x minus 1 squared minus 4. And then we simply need to solve that for x. So to do that, we're going to start by bringing the minus 4 over, which will make that a plus 4. And then we need to divide both sides by 2. And the reason we're doing this is to isolate the squared part. The x minus 1 squared needs to be isolated. And so that's going to give us 2 equals x minus 1 squared. Once you get the squared part isolated, you can take the square root of both sides to get rid of the squared. Now, 2 does not square root nicely, so we're simply going to write that as plus or minus square root of 2. On the other side, we have x minus 1 now. And now for the last step, we can bring the -1 over all the way to the front. And that's going to give us x-intercepts of 1 plus or minus square root of 2. If you're going to plot those, you're probably going to want those as decimal approximations. So we're going to say the x-intercepts are approximately, and we're going to use the calculator to estimate those. So 1 plus square root of 2 is approximately 2.4. And remember, you need to write your x-intercepts as ordered pairs. So that's 2.4 comma 0. And the other x-intercept is going to be, delete 1 minus square root of 2, approximately. So that's about -0.4. And so that takes care of our x-intercepts, well, approximately, okay? Those are the approximate values. Okay, so now that we have the x-intercepts, I think we should go ahead and find the y-intercepts also for part H. And to find the y-intercept means you're going to let x be 0. So we're going to go to our function. F of x, remember, means y, is 2 times, we're letting x be 0, minus 1 squared minus 4, and then we need to solve this for y. So that's going to be 2 times 0 minus 1 is -1 squared minus 4. -1 squared is 1. And 2 times 1 is 2. 2 minus 4 is -2. So the y-intercept as an ordered pair is going to be 0, -2. Okay, now for part I think I've done everything I need to in order to get the graph. So at this point, we're going to go ahead and sketch the graph of the function. We've got our XY axis. I highly recommend that you start with the vertex. So 1, -4 is the vertex. And then we're going to plot the X and Y intercepts. So 0, -2, Y intercept. And we have X intercepts at -0.4 and at 2.4. And then we should be able to make a nice smooth parabolic curve through there. There you go. So one of the ways you can tell for sure if you're on the right track is if the points are positioned in such a way that they make a parabolic curve. Another way you can check is with Desmos. So what we're going to do in Desmos is we're going to input our function, and then you're going to look at the graph and see if it corresponds to what you drew, which ours is looking pretty good. Notice we have the y-intercept 0, -2 verified. Yeah, and so the vertex 1, -4, bam, is verified. And now let's check those x-intercepts. I'm curious to see if we got close on those. So if I click on the x-intercepts, you're going to see -0.4 and 2.4 approximately. So Desmos also verifies those x-intercepts. And that's going to do it for problem number 24. Okay, next example, number 39. This is a quadratic function. We know that because it has an x squared and no bigger power. This quadratic function is in standard form. So I notice that a is -4, and that's going to allow me to go ahead and find the first piece of information, super easy, whether the parabola opens up or down. So to determine if your parabola opens up or down, if a is negative, it's going to open down. If a is positive, it would open up. And now that we know that, the next piece of information, the next easiest thing to find, is going to be whether the parabola has a minimum or a maximum value. If it opens down, this parabola will have a maximum value. And again, we know that if we do a quick sketch where it opens down, you can see the vertex is going to be at the highest point on the graph, which corresponds to a maximum value. Part C, the next thing we're going to find is the vertex. Now, since we're in standard form, we're going to use the vertex formula, which says -b over 2a. b is -12 minus a negative makes it a positive. So that's going to be 12 over 2a, which is 2 times -4, and then f of whatever we get here. Okay, so to simplify, that's going to be 12 over -8 f of whatever we get. Again, I'm hanging on to this spot right here until I get this part simplified. -12 over 8 reduces to -3/2, and now that's going to go in the parentheses here. Okay, so to find the vertex, you find the x-coordinate of the vertex, and then plug that into the function to find the y-coordinate of the vertex. And I highly recommend the use of a calculator for that. -4 times -3/2 squared. Do you see what I'm doing? I'm plugging in to my function. I'm replacing every x with negative 3/2. So next we're going to have minus 12 times negative 3/2 plus 9, which gives me 18. And that is the y-coordinate of the vertex. And so there is our vertex written as an ordered pair. Let's go ahead and write the vertex form now that we have the vertex. So the vertex form is f of x equals a, which is negative 4, parentheses, x minus h. H is the x-coordinate of the vertex. And if it's minus a negative, that'll make it a positive. So plus 3/2. Don't forget the squared. Plus k. And k is the y-coordinate of the vertex. So plus 18. That is going to give us the vertex form of the function. And now I'm going to take a quick trip over to Desmos just to check and make sure that I got that right. So we're going to put in the original problem, f of x equals negative 4x squared minus 12x plus 9. And then I'm going to input as g of x my vertex form, negative 4x plus 3/2 squared, damn, plus 18. Dude, look at that. Turn it off. Let me scroll out some. There you go. Turn it on, turn it off, turn it on. Do you see how it's exactly the same graph? That means that this is exactly the same function. Standard form, vertex form. And so my work is verified with Desmos. Next, part E. It's a part E. Part E. We've got the vertex, we've got the vertex form. What should we find next? How about axis of symmetry? Remember, the axis of symmetry is always x equal the x-coordinate of the vertex, which is negative 3/2. Now, what I've not shown in Desmos is how you can verify that. So if we go to Desmos and type in x equals negative 3/2, you're going to see that that line splits the parabola right down the middle. That verifies that the axis of symmetry is correct. Next, part F. Let's do intervals of increasing and decreasing. That should be pretty freaking easy. Remember, our parabola does open down. So if I do a quick sketch of that, there's the parabola opening down with the axis of symmetry occurring at negative 3/2. Remember, that is an x value. And the increasing and decreasing intervals are also x values. And another thing I haven't mentioned yet, notice the increasing and decreasing intervals, you never use brackets, only parentheses for those. So let's split this down the middle. We can see that on the left, we're coming up, so we're increasing. Remember, you have to read this from left to right. So we're increasing. And once we reach negative 3/2, then we start to decrease. So our increasing is going to be from negative infinity up to negative 3/2. And our decreasing is going to be from negative 3/2 to infinity. Don't forget that those have to be written from left to right. Negative infinity to negative 3/2 for the increasing, and then negative 3/2 to infinity for the decreasing. Okay, next, part G. Let's go ahead and find the x and y intercepts. So to find the x-intercepts, we need to let y be 0. Remember that y is f of x, and so we're going to set our function equal to 0. So that function was g of x equals negative 4x squared minus 12x plus 9, negative 4x squared minus 12x plus 9. And we're going to try to solve that by factoring. So since my lead term is negative, the first thing I'm going to do is divide both sides by negative 1, and that'll make the a positive. 4x squared plus 12x minus 9. And then I'm going to use my 3R method for that. So first we're going to take the lead coefficient and remove it. That's going to leave us with just x squared plus 12x minus, now you do need to multiply that 4 that we removed times the negative 9, gives us a 36. And then if we factor a standard trinomial, we've got our parentheses. We're going to read the signs. Minus at the back makes them different. And we're going to fill in the blanks. Numbers that multiply to make 36, that subtract and make 12. Well, it's not 1 and 36. Maybe it's 2 and 18. Nope. Maybe it's 3 and 12. Okay, so after going through the factors of 36 and not finding a pair that subtracts and makes 12, that indicates that this trinomial will not factor, sadly, so we're not going to be able to solve by factoring, but we gave it a shot. So what is our backup plan? Well, if it won't factor, you've got to sing the song. So here's our A, B, and C from our quadratic equation. And do you know what sing the song means? It means we're going to use the quadratic formula. Okay, so here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. And then we're going to have x equals negative 12 plus or minus square root of some stuff. And to figure that out, I'm going to use the handy dandy calculator. Okay, so I'm calculating the radicand. 12 squared minus 4 times 4 times negative 9, 288. And then, oh my goodness, I'm going to have to see if I can reduce that. We need this to be in simplest radical form. Negative 12 plus or minus, I think it probably will reduce because I know that 288 is 2 times 144. Yeah, let's rewrite that. So 288 I can write as 2 times 144, and 144 is a perfect square. And so that'll get to come out. So here x equals negative 12 plus or minus. The square root of 144 is 12. Square root of 2 is left over. All over 8. And then the 12, 12, and 8 can reduce. 4 goes into all of those. 4 goes into 12 3 times. 4 goes into 8 2 times. And I finally have my x-intercepts, negative 3 plus or minus 3 square root of 2 all over 2. Yuck. Okay, so what I need to do next is I'm going to write my x-intercepts as ordered pairs rounded to the nearest tenth. Since I can't graph more accurately by hand than to the nearest tenth, we're going to evaluate these x-intercepts rounded to the nearest tenth. Okay, so to do that on my calculator, we're going to do the fraction button and do negative 3 We're going to do the plus first. Plus 3 square root of 2 all over 2. And then I have to hit the SD button to get my decimal. So that's about 0.6 rounded. 0.6 comma 0 is one x-intercept. And then we're going to come back here and go back, and change the plus to a minus. And SD, negative 3.6 approximately. Those will be my two x-intercepts. Let's do H, y-intercept. And remember, to find the y-intercept, you need to let x be 0. Basically, we're going to calculate f of 0, which means we're going to have the y value when x is 0. And that'll be negative 4 times 0 squared minus 12 times 0 plus 9. Now, the nice thing about finding the y-intercept, if you're in standard form, is it's always going to be just the constant. Super easy. I hope did you hear that? If you're in standard form and you want the y-intercept, it's always going to be the constant. So as an ordered pair, the y-intercept is going to be 0, 9. For part I, let's go ahead and find domain and range. The domain of any polynomial function, here specifically a quadratic function, is always all real numbers, which can be written in interval notation as negative infinity to infinity. And the range is going to depend on whether the parabola opens up or down, and we need the vertex. So our parabola opens down, and the vertex has a y-coordinate of 18. Okay, so if we do a little sketch here, it's going to open down. And remember, the vertex has a y-coordinate of 18. So the range of the values that y can be, starting at the bottom and working your way to the top. Since this is going to go down forever, the range is going to be negative infinity up to the highest y value, which is going to be 18. And that does need a bracket because that is an actual point on the graph. That means that 18 is included. So I don't know if you caught that or not, but if your parabola opens down, your range is going to be negative infinity to the y-coordinate of the vertex. Okay, as a formula, you could say negative infinity to k, and that will always be a bracket. And if your parabola opens up, like it did in the previous example, your range is always going to be k to infinity. So there's a generic formula for the range. Notice it does depend on whether it opens up or down. Maybe I should stress that one more time. If it opens up, the range is k to infinity. If it opens down, your range is negative infinity to k. Okay, so now that we've found everything that there really is to find, the last thing we're going to do is we're going to sketch the graph. And I'm going to make mine a little bit tall like this because I know where the vertex goes. So negative 3/2 is negative 1.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whew, way up here at 18. Negative 3/2 and 18. That's the vertex. Next, let's do the y-intercept. 0 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And the x-intercepts 0.6 which is about there. Negative 3.6, which is about there. And then if we sketch in our axis of symmetry, which you don't have to, but it goes right through the vertex. Once you have the vertex and the x and y intercepts, you should be able to connect the dots and make a parabola. And I am not the best graph sketcher, so there you go. Something like that. And now we're going to use Desmos, I think, to verify some of these points. Okay, so if we come to Desmos and input our function, f of x equals negative 4x squared, right here, the way that it looked at the very beginning, and I called it f of x, that's irrelevant, okay? F of x, g of x, whatever, equals negative 4x squared minus 12x plus 9, minus 12x plus 9. We can click on the vertex. Negative 1.5 is, as an improper fraction, negative 3 halves, and 18. So the vertex is verified. The y-intercept, 0, 9, is verified. And now for the x-intercepts, which were 0.6 and negative 3.6. There it is, 0.6, negative 3.6, verified. So Desmos verifies all of that information as well as the graph. Man, Desmos is nice, but it is not allowed on the test. So if your function is in standard form and you have the Casio ClassWiz, it will check this stuff for you. If we go to menu and down to the equation/function app, we have a polynomial function of degree 2. And you'll see there it shows the quadratic equation. Every quadratic function is going to be of degree 2. We can simply input the values of a, b, and c. So negative 4 equals, negative 12 equals, positive 9 equals. Notice that it is going to give us the x-intercepts exactly in simplest radical form. Negative 3 plus 3 square root of 2 over 2. If I hit equals, it's going to show us the other x-intercept is negative 3 minus 3 square root of 2 over 2. And remember, if you need those as decimals with the calculator, you can just hit the SD button right here, bam, and it's going to give it to you. So there's the x-intercepts verified. If I hit equal again, it's going to tell me maximum of, and here, look, it says x equal negative 3 halves. Guess what that is? That's the vertex. Look at that. That's the x coordinate of the vertex. If I hit equals again, look at that, y coordinate of the vertex. So the Casio ClassWiz not only is going to verify your x-intercepts, but it will also verify your vertex. And that's all that the ClassWiz does, but that's a lot, in my opinion. It does a lot to check there. So now that we visited the ClassWiz, before I close out the lesson, I do want to illustrate a couple of points that make graphing quadratic functions super easy, okay? Just remember, if a is negative, your parabola opens down. If a is positive, it opens up. Also, if you know the vertex, if you know h and k, then you've automatically got the axis of symmetry because it's always x equal the x coordinate of the vertex. You also have increasing and decreasing if you know the direction it opens and the vertex, and the domain and range. Super easy. The domain is always all real numbers, and the range is going to always involve the y-coordinate of the vertex. So from what the calculator will give you, you can get the x-intercepts and the vertex gives you the axis of symmetry, the increasing and decreasing, and the range. That's going to do it for this lesson. So if you have any questions or comments about anything that I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.